Hi, this is Cliff from Redwood Tutoring. I would like to talk with you about factoring a cubed plus b cubed and a cubed minus b cubed. Well, this is called a sum of cubes. And this, because it's a subtraction, is called a difference of cubes. Now, before I actually do some problems, I'd like to review some common cubes. Knowing these will help us to be able to more easily do these type of problems. Here I'm just going to write 1, 2, 3, 4, 5, 6, and then here I'm going to write the corresponding cubes. Well, I know that 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and 6 cubed is 216. So these are the numbers that come up very frequently when you're doing these types of problems. It would be good to be able to recognize them as perfect cubes. Let me show you the pattern. What's going to help us to do these problems is the acronym SOAP, S-O-A-P. S stands for the same, O stands for opposite, A stands for always, and P for positive. So, if I have, for instance, the sum of cubes, a cubed plus b cubed, here's how it breaks down. It breaks down into a binomial times a trinomial. And as for the operations, these two operations are the same, so that makes this a positive. These two operations are always opposite, so that makes this a subtraction, a negative. And then the final operation is always positive. That's going to be a plus. So now all I need to do is fill things in. Well, if I have a cubed plus b cubed, this is going to break down into a plus b. And then as for the trinomial, this breaks down into descending powers of a and ascending powers of b. So it's going to be a squared minus ab plus b squared, descending powers of a and ascending powers of b. Let's go ahead and do the difference of cubes. Say I have a cubed minus b cubed. Well, this also breaks down into a binomial times a trinomial, and the same pattern holds. So since this is a minus, these have to be the same. This is going to be opposite, so that's going to be a plus. And this is always positive. I have a cubed minus b cubed, so this is going to be a minus b. And then here I'm going to get a squared plus ab plus b squared. This is descending powers of a and ascending powers of b. Excuse me. Now, some of you might be thinking, as for this trinomial, can it be further factored? Well, almost every time, this is going to be a prime polynomial. It cannot be factored any further. Let's go ahead and do some specific problems. I'm going to erase this to get some board space. Let's say that I have, for instance, x cubed minus 125. Well, first of all, I recognize 125 as one of my perfect cubes. I know that this is just 5 cubed. And since this is a difference of cubes, I know that it's going to be a binomial times a trinomial. Furthermore, I know the signs. These have to be the same. These are opposite. And this is always positive. Now, here's the way that the binomial goes. It's going to be x minus 5. And then I'm going to go in descending powers of x and ascending powers of 5. So it's going to look like x squared plus 5x plus 25, because 25 is just 5 squared, descending powers of x and ascending powers of 5. Let's see if we could do the next one. What do I have here? I have c cubed plus 64. c cubed plus 64. Well, 64 is another one of those numbers that I recognize as a perfect cube. I know that it's just 4 cubes. So this is going to break down into a binomial times a trinomial. And since this is a positive, these have to have the same signs. These are opposite, and this is always positive. So what I'm going to have here is I'm going to have c plus 4, and then I'm going to have descending powers of c and ascending powers of 4. So it's going to be c squared minus 4c plus 16, because 16 is just 4 squared, descending powers of c and ascending powers of 4. Let me do a few more of them, and as I'm doing them, see if you could complete the problem before I write it up. See if you could beat me to it. Say I have y cubed minus 27. Well, here again, 27 is just a perfect cube. I know that 27 is 3 cubes. See if you could fill in the rest of it. I know that this is going to be a binomial times a trinomial. Whether it's the sum or difference of cubes, it's always a binomial times a trinomial. Also, I know that these are always the same sign. These are going to be opposite, and this is going to be always positive. So what I'm going to have here is I'm just going to have y minus 3, and then descending powers of y and ascending powers of 3. So this is going to be y squared plus 3y plus 9, because 9 happens to be 3 times 3, 3 squared. All right, let's do 2 more. Let's say that I have this problem. This is a little bit more advanced. 8a cubed plus 1. 8a cubed plus 1. I recommend that you guys do this in 2 steps. Well, I know that this is just quantity 2a cubed, and I know that this is just 1 cubed. So this is a sum of 2 cubes. This breaks down into a binomial times a trinomial. Well, these two have to have the same sign, then the opposite sign, and this is always positive. Now, here I'm going to use the 2a. It's going to be 2a plus 1. Now here, it's going to be 2a squared, 2a times 1, and then plus 1 squared. Notice how I have descending powers of 2a, 2a squared, 2a to the first, and then no 2a, and then ascending powers of 1. My final answer is just simplifying this. I get 2a plus 1 times, this is going to break down to 4a squared minus 2a plus 1, and that will be my final answer. Let me go ahead and just do one more problem. One more problem that I think is common to have. Common problem to trip students up. Say I have 8x cubed plus 64. Well, there's a little bit of a trap going on with this problem, because this right here is a perfect cube, and so is this. But you don't want to directly go to our formula. Instead, what you should ask is there anything that they have in common that I could factor out first? Well, as it turns out, they have an 8 in common. We should factor that 8 out first. And then I'm going to be left with 8 times x cubed plus 8. Now this is a sum of 2 cubes. We're going to go ahead and keep the 8. And then this sum of cubes breaks down into a binomial times a trinomial. Now, these signs have to be the same. These signs opposite. And finally, always positive. So this breaks down into x plus 2, and then x squared minus 2x plus 4. Descending powers of x, and ascending powers of 4. All right, well, that's my last problem. Thank you for joining me, and have a great day.